stuff that we need for life, right? So I love it. Somebody said, what are we learning today? They're ready to go. All right. I want you to write on the white. Let's pull the whiteboard. Let's do it. Brain dump. Anything you remember from last week. Don't make me too sad. Okay. Last week we talked about, hey, James, what's up? Do you not have a permission? You're welcome to talk or use your... You don't? Well, that's not normal. I'm looking right here. Miss Schaefer, am I missing something?
The mic. You want the mics on?
Oh, yeah. Sorry. I didn't realize it. I had it. There we go. Oh.
There you go. Oh, we both did it. Sorry, I won't hit it this time. You hit it.
No, so I asked you to fix it, and then you told me, and I did it anyway.
That's all right.
All right. So, James, go ahead.
I will not. I just want to say I will not be here tomorrow as Daddy has an appointment in Columbus and Mommy's going, so I have to go too because we're like an hour.
And I'm sorry, my internet connection is bad.
Just letting you know.
It's very bad right now. I had to turn on the hotspot.
Well, that's all right. It's that kind of Monday. Thanks for letting me know.
Someone's hacking our internet, or somebody, or just the internet issues.
I'm sorry, that was me. I was hacking your internet. Just kidding. I'm just kidding. I'm just teasing you, Jonathan. Awesome. I love what I'm seeing. Covalent bonds, hetero, carbon, elements, hydrogen, ionic, compounds. This makes me so happy. Yes, we learned that carbon is our favorite element because it is a good friend, right? It is a stable friend. It is not somebody that partners up with one element and forgets the rest of us, right? How many bonds can carbon make? Yes, Cassandra, right? Carbon makes 4 bonds, and that is perfect because we like these friends that we can plug into, right? That don't leave everybody behind. What type of bonds does carbon like to form? Covalent or ionic? Yes. Covalent. And we see the nature of this bond because there are those 4 openings, right? It will tend to share covalent bonds with other elements because of basically its personality, right? It doesn't have just one valence electron left that it's trying to fill. So some of these elements are so close to being full that they get angry, hangry for one more electron. So these electrons that have a valence shell that have 7 electrons in them and they just need one more, they get real, edgy, irritable. They're like, gimme, right? They don't want to share. They don't care. They're just like on a mission to get that one last electron to, finish their shell. Mission accomplished. But carbon's cool. He's chill, right? He's got extra spots that he knows he needs filled. He's got 4 valence electrons. So he's working on it. It's a project, but he's friendly about it. Yeah. Absolutely. So we love carbon. Carbon is our friend in every living thing. Okay, I want you to think, I wanted to grab a banana, but you can imagine what a banana looks like, right? Pretend I'm holding this banana. All right. The banana that's off the tree and in my hand in my kitchen. Is it living or non-living? All right, hold your banana up, Lizzie. Hold it up for us. Yes, it does, Naya. We do have an end of course exam. Right. All right, so Lizzie's banana. I can't see Lizzie. I want to see the banana. Where's Lizzie? Can I put you up, Lizzie? Do you care? Sorry, I hope you don't mind me doing that. There's Lizzie. All right, so Lizzie's banana. You are all right. It is non-living right now. Why is it not living? I saw somebody say it. Say it. Let's say it again. Why is it not living? Her banana's not showing. I tried to pull her on the screen. Can you see her now? I'm presenting her. Hopefully you can see her. Well, some of us can see her. I tried to present her on the camera. Oh, I didn't realize you were muted. Yep, here you go. You're unmuted. You're welcome to talk. You want to tell us why your banana?
So this banana is non-living because it's no longer gaining nutrients and it's no longer growing. When it is attached to the tree the banana tree, it's gaining nutrients, it's growing, it's getting what it needs. But here in my hand, it's not living anymore because it's no longer gaining nutrients, it's no longer attached to the plant.
Perfect. Now, I love that. Thank you so much for tell Lizzie how awesome she is for being so brave to pop up there and share. I don't know how to unpresent you. I might just have to present myself. Yes, she's amazing. Love it. Thank you, Lizzie. It's always such a pleasure to have you on your mic and on your camera. You all make a big difference in this class when you show up and participate. All right. So the other thing that Lizzie and that banana have in common is that even though that banana is now not alive, Lizzie has carbon. She is made up of cells that have carbon in them and need carbon to function. And guess what's still in that banana? Carbon. Carbon. Everybody type carbon, right? Carbon is famous. All right, because this is how we date fossils, guys. It's so cool because anything that was once alive, it doesn't all of a sudden lose everything in it, right? Like it's just no longer growing or reproducing or going through those living things that we talk about. So it just is non-living. So those characteristics aren't there, but the insides still remain the same. So as our bodies and things decay, as Lizzie's banana decays, it starts to decompose and those carbon compounds start breaking apart. Yes, she got a snack. They start breaking apart. So when we look at fossils and we try to date fossils, we actually look at the amount of carbon decay in those fossils to tell us how old they are, right? We could do the same thing with decomposing matter. We're going to say matter, okay? Because all things that were alive or are living now all have carbon in them. Carbon is famous. All right. When I say ionic, what do you say? I say ionic. Ionic equals what? It is a bond. Tell me what kind of bond. Tell me about the nature. Yes, ionic steels. Everybody type ionic equals steels. Yes, Snatchy. Everyone type it in. I know it's annoying that I make you type, but it's another way of putting it in your brain. I promise. Ionic steels. Yes. What about covalent? Covalent bonds do what? Share. They're the nice bond, like carbon, your chill friend that you want to hang out with. Covalent shares. Everybody type covalent equals share. Good. I know that was a little off base, but this is good because this leads us into today. This jogs our memory. Who remembers anything about our hydrogen bond? What's so special about our hydrogen bond? Yeah, it is covalent and it is the weakest. It is the weakest bond. We always view weak as being bad, but honestly, being weak is what makes having those weak hydrogen bonds is what makes water famous, right? It is what makes water the universal solvent. Everything that's alive basically needs water. And we need it because of how it is made, because of its molecule form, which is what we're going to do today. All right, that is what we're going to talk about in the last 15, 20 minutes of class, is why water is so awesome, how its molecule is designed, and that's why we need it. All right. So, do we have any readers in the house for telling me what we are going to do today as far as learning about water? Gracie, can you read the first one? Sam, can you read the second? Is there a third reader? Lizzie will read the third. All right. So, Gracie, Sam, Lizzie, you are up.
All right. Firstly, can I be heard before you know,
Yes, we can
I
hear you.
read?
Thanks,
From
Gracie.
sure, thank you. Explain why water is an important molecule for living things. Thank you.
She's bringing the accents this year. I love it. Sam, you're up. Number 2.
Can you guys hear me?
Yes.
What are the unique properties and characteristics of water?
Yes, I love it. It lives on.
Explain the importance of cohesion and adhesion properties of water.
Thank you. Thank you guys so much. Thank your classmates. Tell them they're wonderful. All right, that's what we're going to talk about today. We're going to talk about why water is important, its unique properties, and the properties of cohesion and adhesion. If you could give me one emoji with how you feel about those goals, today's goals. If you're like, yeah, I could teach you those things, Mrs. Rittenhouse, I want you to give me a green smiley. If you're like, maybe I could, I'm not sure, give me a meh. And you're like, what is cohesion and adhesion? Give me that sad face and be like, listen, I don't know those words. And the good thing is, guys, you don't have to know those words, okay? Awesome. All right, this poll is for me, not for you, so don't worry, I'm not presenting it. But it looks like we're in between happy and meh. So this should be a good lesson to jog our memories on things that we do know. And then we'll come back and hopefully should be able to nail smiley faces on the last slide of the review of these goals. So water. All right, this is what the molecular diagram looks like for water. Water is what? If I had to ask you, what's another name for water or a nickname for water? Can you put it in chat? What's a nickname for water that you've heard of? Yes, H2O. There are other water nicknames, but I would say H2O, fish home, yes. H2O. And that is because literally that is what water is made of. 2 hydrogen atoms, and 1 oxygen atom. What can you see is happening right here? What is this showing us that I just circled? Anybody? What did I just circle? Yeah. Shared electrons, a covalent bond, sharing electrons. Perfect. So you're identifying what we talked about last week. This is great. So this is a bond that we see between hydrogen and oxygen. They share these electrons in their valence shell, right, to make their electronic force fields happy. All right, so this is a happy molecule. You can count the electrons, 1, 2, 4. Let's count them for oxygen. 1, 2, 3, 4, 5, 6, 7, 8, right? And then we see its innermost shell is full, and the innermost shell, we only need 2 electrons, right? From then out, every time we add a shell, we need 8 electrons to fill it. All right. What do you notice about the shape of water? What do you notice about where the bonds are, the shape of it? What are some just okay? Yes. Ooh. Upside down Mickey head, Sam says. How did you know I was going to go there with it? You're right. Right? I love Disney. I don't know about you guys, but we are Disney fans at my house. Anytime we go to Florida, we try to sneak in a trip if we can pull it off. But yeah. All right. Water looks a lot like Mickey Mouse. What is here in the middle? What is the center molecule? Somebody want to label it? Ooh, my kids were watching that yesterday, Dylan. Yeah, what? Oxygen. Good. We have oxygen as the big part of Mickey's face. And what do the 2 ears represent? That is totally fine, Lola. This class is, hold on. Okay, sorry. Yes, hydrogen. Yes, we got hydrogen ears. So we've got the big oxygen face and the 2 hydrogen ears. A lot of times in our diagrams, it will flip the hydrogen so it's on the bottom. We do that because a lot of times their hydrogen would weigh more, right? So it just hangs Mickey upside down. But because of this shape, what did we learn in Unit 1? The shape of something equals what? Shape equals what? You do. Think about the shovel. Think about the shovel, the picture of the shovel and the alligator mouth. Almost. These are all good. Shape equals. We're talking about the shape, Dylan, of Mickey's head. This is the shape of a water molecule. In Unit 1, we talked about a shovel. And we were looking at the shovel and we were like, it's pointed. We looked at a hang glider. And we were like, oh, the hang glider's shape is very aerodynamic. We looked at the shape of the alligator tooth and it was pointed and big and it had a huge mouth. Let's do, yes! Cassie got it. Cassandra got it. Sorry, I like make nicknames. I don't know if you like that, Cassandra. Shape equals function. Everyone type that for me. Shape equals function. You had to pull that out from a while ago. Does everyone remember that now? The alligator tooth and the dustpan, the hang glider. And we talked about how in biology, it's really crazy because just like a pillow that looks like soft and fluffy, like you would guess, wow, I might lay my head on that. That in biology and living things and even chemistry, that the shape of objects is so important because of their function. And we're going to find that with water today, is that this shape, this Mickey Mouse shape, is what makes it so important. This molecule, because the ears are on one side, the bonds weigh the molecule down and are on one side. It makes the water molecule, even though the charges are all there. Does that make sense? The ionic charge, because the electrons are all there, it's not looking for more electrons. It's not positive or negative seeking out that, but because of how those hydrogen ears actually hang down, let me show you this slide. Because not that slide. Where are you? The hydrogen ears actually hang down like this, right? Because the hydrogen actually hang down because of their weight. You see this weight here, 2.20, 2.20. What is 2.20 plus 2.20? It's 4.40. All right. So it weighs 4.40. And you see that this over here is only 3 of oxygen. So this is going to hang down lower. It actually weighs more. So because those bonds droop, even though this molecule is happy and all the bonds are filled, it gives both sides of this molecule a different charge. You have a positive charge on one side with the ears and a negative side on the other. Right? They're shared, but they're shared basically unequally as far as it goes. It's like not symmetrical. Does that make sense? Like our faces are symmetrical. If I split my face in half, I'd have one eyebrow, one eye, one same-ish half of my nose, and the same half of my lips and teeth and chin. But water's different. Because of the molecules weighing more, they droop. And it still allows a happy electron shell to be a molecule that has a dual charge. A dual charge. Does that make sense? Water is awesome because its shell is full, but it has a dual charge. It has a positive and a negative charge. Yes, we're getting it. This makes me so happy. All right, that is why we call water the universal solvent. Okay? Basically, whatever we put in to a cup of water, it doesn't matter if it's positively charged and I throw it in, or if it's negatively charged and I throw it in. Water is going to take it and pull it apart and dissolve it, because guess what? Water has a positive charge and water has a negative charge. So you can see right here in this diagram that when I put salt into water, what water starts doing is it starts plucking those salt bonds apart. It breaks those because it has the positive and the negative pull. It's got the magnetism on both sides. Does that make sense? Yes, like the Grand Canyon, the high and the low lows. And anything we put in, almost anything. That's why we call water the universal solvent. That I don't care what it is that you put in there, if you leave it in water long enough over time, you're going to get plucked apart. And you're going to come back and there's going to be, you're not going to see it. Because I could put salt in here and it's going to dissolve it. I could put sugar in here, it's going to dissolve it. I could put a hot dog bun whole in my water, and when I come back at some point, it's going to look nasty, but it's going to be completely broken apart. Because water is the universal solvent. Yeah. It does. All right, which gets us to cohesion and adhesion. All right, let's go ahead. I get overwhelmed by diagrams, so I don't know if anybody else does, but I like to do it. I like to cover stuff up so that we just get little pieces at a time. Okay. So in cohesion, it's like when you come together, right? CO, come, co means two. I want you to remember come together, whatever. It is mutual. It is when two of the same molecules stick together. All right. So what that means is water sticks to water because of cohesion. So, like water in my cup, there's strength in there because they form a bond with one another. No, I did not put a hot dog bun in my water, I promise. Yep. All right. So, cohesion. I want you to say cohesion is like to like. In this circumstance, it means water is stronger together. When you see water, you can know that it is bonding together. There is a tightness to the surface of water because all of the water molecules in a lake or a puddle or in my cup are kind of hugging together. They like each other, they stick together. All right, like things stick together. All right, that is cohesion. Now, adhesion. Adhesion is the mutual attraction between molecules that are not alike. Because of water's shape, it also has a mutual attraction to other stuff. All right, so it's going to bond to other things. So not only is water going to attach to water, but the things that are on top of it. All right, like bugs. Have you ever seen those bugs that seem to like walk on the surface of the water in puddles or ponds? And you're like, dude, how do they do that? They don't do it because of how the bug is. Now, I mean, a big enough bug is not going to be able to have that, right? But because of how the bug is formed, and because of cohesion of the water, and because of the adhesion of the water, we get what we call surface tension. All right. And look at all these happy water molecules. They're so impressed with themselves, right? The water molecules, they're bonding together and they're like, ooh, we're so strong. We can hold you. And they're also bonding to the feet of that insect. All right. There's like an attraction, right? They haven't like stuck, they don't stick together. It's not like sinking sand. All right. But there is strength in numbers with water because they hold together and they create a strength, and they also can form a bond because of their shape and their polarity. They can also have that adhesion with other things. Does that make sense? And if it doesn't, will you type your questions in chat? Type your questions in. Because shape equals function, we have a polar molecule, meaning at the top is one charge, at the bottom there's another charge. Because of their polarity, they're nice molecules. Their cohesion, they like to hang out with their same molecule. There's the same in strength and numbers, and with that adhesion, they have that top part, that other charge that says, "I can bond to you too. I have attraction to you too." Good. For those that are participating and here with me, we've got a good understanding of what that looks like. All right, so let's see. Let's do this quick check really quick. Would somebody like to read number 1? All right, Lily, go for the first question.
Which statement is true about water molecules? You want me to read the answers too?
That'd be great.
The oxygen atom has a negative charge. The hydrogen atoms do not share electrons. Water molecules move randomly around each other. Or water molecules cannot easily dissolve other substances. Thank you.
Yeah, perfect. Let me take you here. Remember this. And then let's come back down. What do you think? It is A. That oxygen atom is going to be the part of the hydrogen part of the water molecule, right? That has a negative charge. Good. They do like each other. They may move randomly around each other, but the most accurately question or answer is going to be this. Good. Let's look at number 2. Sam, will you read number, or wait, Gracie, will you read number 2? And Sam, you can read number 3.
Oh, Gracie, I don't think your mic's on.
Oh, I turned it on, and then it went on, and then it was off. Nero loves me. How does water relate to the ability of a living thing to generate energy? The water is responsible for generation of energy in the cell. The cell is an aqueous environment.
Good.
Without the proper balance of water, chemical reactions in cells could not take place. Thank you.
Good. So how does water relate to the ability of, I really don't love this question. I'm going to be honest. Because I feel like, listen, the cell is an aqueous environment. All right. We'll learn about that. It is a place where the cytoplasm allows things to go in and out of the cell, diffuse in and out of the cell. Without the proper balance of water in cells, chemical reactions in cells can't take place. It can't. And water is responsible for the generation of energy in the cell. It's part of breaking them down, but it's not the source of the energy. So it makes it challenging. Everyone is typing C. I would say, gosh, C is the best answer. All right. It is the best answer. I don't like the question, but it's still the best answer. And I may remove this one from your quiz because I just don't like it. I feel like it's asking this, or kind of saying the same thing in a multiple different ways, which we don't want to confuse you. We want to confirm your understanding. All right. I know. All right. Last but not least, Sam.
What is the most important role of hydrogen bonding between water molecules? A. It enables water molecules to bond to each other. B. It allows oxygen and hydrogen atoms to be charged. Or C. It allows cells to keep water in balance.
Good. What do you guys think? Again, I love that you're participating, even if you don't know, because this, whether you get it right or wrong, this is going to be like a tally mark, a way of inputting knowledge into your brain. If you answered A, you are correct. So it says, think about cohesion. It is important because water molecules bond to other water molecules because of their shape. All right. Because of their shape. And that is an important characteristic of water. Great job, all 3 volunteers. Thank you. Thank you so much. What do you guys think? Did we accomplish our goal today? Yes or no? Did we talk about water? Water is important for all living things. Did we talk about how its unique property and characteristics make it so valuable? And did we go through the importance of cohesion and adhesion and what they are? I'm seeing a couple yeses. I need more than 2. Give me a emoji how you're feeling today. That's okay, Dylan. Good. So we're feeling happy and we're feeling met. And I like that. That's how I like to end the lesson. I did my part today by teaching you the content. So now what your job is to take it the next step. Okay. Learning is not just my job. It is not just your job. This is a us thing. So what we need to do is take a next step. What your next step is today might be different. All right, there is going to be a quiz. So that might be your next step. Maybe you want to go back today and you want to make your Mickey. You want to make a water molecule. When I used to go to my college courses, I would go back to my dorm room every single day and I would take my written notes and I would make them into pictures for everything that my teacher taught. And I wrote notes down about, I would go take and make pictures and diagrams for myself with my own little pack of markers and paper, because that helped me as even a college student get it put in my brain in a way that I could understand. Okay? So I don't know what you need to do. Maybe you need to go and read today. Okay? Maybe you need to read. Maybe you need to go. Everybody does need to take the quiz. All right. But I need you to take a next step and be responsible for your learning as well. The last question was A. Okay. So this is now in your court, right? As you leave, because I don't want you to be late, I would love you to type into chat what cohesion or adhesion is. You can type co equals, add equals. Type that in chat to me. We're going to start tomorrow again into some new fun stuff. One of my favorite things to talk about in science. Yep, you are 100% right. Yes, Sam. Does somebody have a question? I saw that before we started. Oh, yay, Gabby. Perfect. The quiz, reading, drawings, whatever you need to do to help cement this up here. If you have questions, help sessions are going to be at 8 o'clock, so I can see you at 8 o'clock before class. Give me an email, send me a call. We can go over things together. Have a great day, guys. Thanks, guys.
Bye, everybody. And I hope if anybody's sick, you get better.
I know.
We're talking a little bit about it in chat.
I feel like everybody's got something. It's that
Awesome.
season. The season starting
early.
Yeah. Don't like it. My chat like randomly goes back to like very past dates. It's very strange to me.
Mine was doing that today too. And then I